Another session of physical sciences, this time around chemistry. Question number 3 in a normal question paper, that is physical properties. Now what we need to know, mainly there are two things here. The the physical properties themselves. Physical properties, you need to know those, and then know the variables to answer some few questions. The last one will be about the intermolecular forces, how to use intermolecular forces to explain in this case. Now, starting with this one, we know that we have got three physical properties, which are the boiling point, the melting point, and the vapor pressure. What's the difference between the three is that there are keywords which are putting the three into the right context. Please know that one, the right context. Now, boiling point is a temperature. I mean that when you define boiling point, you must tell us that is a temperature at which, that's when now you can continue. Also, the melting point will be the same thing, to say a temperature at which, in this case, remember, it will be which a solid and the liquid phase are in equilibrium, whereas the vapor pressure becomes the pressure exerted by vapor. In this case, if you want to continue, will be at equilibrium with this liquid in a closed system. Very important three definitions. Boiling point being a temperature at which the vapor pressure and the atmospheric pressure are equal. Melting point, a temperature at which the solid and the liquid phase are at equilibrium. Vapor pressure, the pressure exerted by vapor at equilibrium with its liquid. Now, let's start with the most important one, which is variables. We have got three types of variables, remember. We have got the independent variable. Normally we say, when the learners, they must know that if in a question paper we are given these two columns, therefore the first one will be independent, the second one will be dependent. If you are given three columns, like in this case, therefore the first one will be independent, and the second one is controlled, the last one is dependent. That's the easiest way of answering the examiner's question from just a diagram given there. Now the variables, we have got let's start with the independent. Which variables can be independent, and then which variables can be controlled. Remember, controlled variables remains the same. And then which variables now can be dependent variable. This one is all about this section. Fine. We start with the easiest one of them all, is the dependent variable. There are only three, as we mentioned. These dependent variable are the physical properties. Therefore, it's your boiling point, your melting point, and the vapor pressure. Remember, please note this one. Boiling point and melting point, the stronger the intermolecular forces, the longer the chain length, then the higher the boiling point and the melting point. But when coming to vapor pressure, when the boiling point goes up, then there's a relationship between these two. The higher the boiling point, then the lower the melting point. So the lower the boiling point means that that type of a liquid vaporizes easily, then it will build up high vapor pressure. Now let's come to this one. I want us to do it in a simple way that it will make your life very easy in this section. See how easy is the section now. Let's start with the when we are comparing the same homologous series. What will be the independent? In this case, the easiest will be the chain length. The moment I'm comparing alcohols, all of them, or ketones, all of them, chain length will be the independent variable. That's the easiest. The second easiest will be now, if they are independent, I might be, if they are the same, I might be, in this case, the independent variable can be your molecular mass. Yes, and then the next one again, if they're the same, I might be in this case talking about if the chain length, some people they talk about surface area, is fine. You can talk about the surface area as well. Molecular mass, I think these two will make it for the same. Now let's say you are comparing different homologous series, comparing alcohol with the alkane. Then what will be the independent now? Because there are different homologous series, then the homologous series is the one that we are changing. Homologous series. And once you deal with the homologous series, obviously the issue of functional group comes in. Remember, a functional group is not a homologous series. Functional group. But in a homologous series, we do have functional group, yes. Then the last one will be your strength of intermolecular forces. The strength of intermolecular forces of IMF. Fine. Now what can be controlled mainly will be 4 or 3. 1, if they are the same, I can control the number of carbon atoms, C atoms, number of C atoms. I can control the molecular mass. I can control the homologous series or functional group. Series or functional group. I think that's all that you can control here, which is very easy. Now, how can we use the independent variables and the dependent variable? We have to answer 3 questions that can come in the examination. The first one being an investigative question. Investigative question. This one will be, if you want to make your life easy, just remember this phrase, the frame. What is the relationship between the first variable, mainly the independent, if you don't want to confuse yourself, and the second variable, which is a dependent variable. Put the question mark for punctuation there. Fine. And the second question that you may answer with the variables is your hypothesis. Remember, hypothesis is just a prediction. So simple term, we talk about prediction here. So now, what will be your anticipation if I've got chain length and boiling point? Then you will have to use now the word increase, decrease, or increase, or decrease, or decrease, increase. So you can use this, just mention the 2 variables. Example will be an increase in chain length. This is an example. Increase in chain length or in surface area, decreases boiling point, the boiling point. Now remember, this is a prediction. It doesn't have to be correct. You are just predicting. The last one that will be based on the data is what we call conclusion. Please be able to write conclusion. Very few learners, they don't know how to write conclusion because they normally think relationships are a conclusion. If I've got A and B here, and then this is the graph, they say conclude from this one. You can't say A is directly proportional to B. That is very wrong. It's a relationship, that one. Therefore, in simple terms, conclusion is either agrees or disagreed with hypothesis, but the conclusion is based on the data that is collected. According to this graph, which was drawn from the data collected, then I will say, according to this, the independent variable, remember in mathematical, we've got this, and then the vertical axis is the dependent variable. Therefore, our conclusion here will be now increase in B, or as B increases, increase in B increases A. Increases A. As the number of carbon atoms increases, the boiling point increases. Or increase in the number of carbon atoms, increase in the chain length, increases the boiling point. So I think you get that. So that is the conclusion. So it's based on the data You don't just draw conclusion anyhow. I think that is about the variables now. So let's pause for now and drink some water, and then come back and talk about now the issue of intermolecular forces and how do we use them to compare, get those 7 marks in this question. Thanks.